Okay, so I'm sorry, that's a Klystron tube?
It's a Klystron power supply. It's the power supply for the Klystron, and it will go down to 40 hertz, CPS, cycles per second.
Pretty good stuff.
Now, John, is this, do you have Klystron tubes here?
Yes, actually, they're in boxes.
Okay, so you haven't plugged them in lately?
Not since I was with Peter filming in here.
Okay.
Have a another extra power supply, which would be towards the used to be an entrance there.
So what are you thinking in terms of ELF then, Gary?
Well, you know, that's interesting. ELF, of course, Kino has predicted certain ELF effects.
This is one of the main units for the Magnetron in there, modified, the variable tunable Magnetron. And as you can see on the side of the door, whoops, ooh, that was slow. Little plate that comes off where I bolt on the plumbing.
This one?
Mm-hmm. That's the guy.
Now, when you are running for levitation effects, what's your test setup? What test setup do you usually use?
I use a lot of machines that are interconnected. This one, use all the back stuff in there. And
okay.
It's not like I have to disconnect it or I can't move in here.
Yeah.
Yeah.
Right. So as soon as you connect these, it would be very difficult to get around in here.
Yeah, because even in the other room, stuff comes out like cables to operate certain RF operators and static generating equipment and that kind of thing.
So when you operate with static at the same time as,
I have a full electrostatic, yeah.
As well as electromagnetic all at the same time.
Electromagnetic and Tesla waves. And
this coil, do you use that for statics, or is that just something you pulled off the boat?
oh no, I built that.
You built it?
Yep. I used to build coils. That's just a baby one.
Yeah, that's like a, what, 3-foot Tesla coil?
You're pushing 4 feet on the with all the stuff on top.
So what voltage can you get out of that thing?
Roughly half a mil.
Half a mil.
That's.
So you got a half a mil Tesla coil.
Yep.
Yeah.
They used to have like 10 million volt types.
So you got that thing. When you get that thing going, then you have a good static field. And so what do you use for your electromagnetic field? These magnetrons?
I use magnetrons. I use signal generators. I use Tesla coils, and for electrostatics, I use static generating ion source equipment.
Ion source.
I don't have a Van de Graaff here. I use
that's what
source.
you use, Van de Graaff?
Yeah. So.
What do you use here? Do you have anything here that?
In statics? Yeah, I have static guns.
Oh.
Well, Gary, one of the things you'd asked about was, would it be possible for John's equipment to be producing gravity waves?
Yeah, I'm wondering, because when you're running light through a strong magnetic field, the Gertzenstein effect predicts gravitational waves.
Mm-hmm.
So I'm wondering if you've ever attempted to run, electromagnetic energy through a strong static magnetic field.
Oh,
have you ever set up static magnetic fields?
Huge stuff, yeah. This setup here is like a baby setup compared to what I once have, which I have drawings of it in a book that I just recently found.
Oh, okay.
Which may be helpful for you.
Yeah, I'd like to look at that. And
because this only can cause minor levitation effects compared to the 1980s.
Okay.
Which were dramatic things.
That was more dramatic in the 80s.
Well,
did you use the same order of Tesla coil, or that's when you were using the bigger Tesla coil?
I actually was using three huge Tesla coils.
Three Tesla coils at that time, and those were the 10 mil.
10 mil, but high Qs, meaning that they wouldn't. Like one was not high Q, so it'd spark over if you wanted to spark over. Then
High Q meaning it didn't spark.
Yeah. So high Q types I'd have going.
Yeah, the interesting thing I find about your Tesla coils is they're the coil style, and so yes, you are generating an enormous static field, but at the same time, because it's a coil and you've got current running through the coil, you're also generating an enormous static magnetic field. So that very well could have been the source of your static magnetic field, is the coil itself.
I'll start from Tesla coils and I try to get away from them.
You just tried to get away from them.
Yeah, by using vacuum tube oscillators and that.
Why
to the
you didn't
coil.
like the sparking? Why did you try to get away?
No, just to improve the equipment from the very first setups I had a long time ago to more advanced setups. That's when I got into magnetrons and clystrons and signal generators and different
So your
waveforms.
goal was mostly what, the material science stuff, where you were melting and merging materials, or was it just
Simply,
to play around?
well, that
See what you
is,
could
no, that's a side effect. If the frequencies seem to shift, this effect would happen.
Okay. If the frequency was shifting.
That's what, yeah, this is what we feel.
I'm wondering if I could, just with a couple of quick questions. The first one was kind of a pass-me-down question. In terms of funding, how much would it cost in terms of dollars, do you think, to set up your lab to be able to produce the Hutchison effect again? The classic effect.
The classic effect, probably, if I started from the basic U.S. government test.
Sure, the documented phenomena that's been interesting a number of our government friends recently, I guess.
Yeah, there were estimates and estimates many times over, but of course the cost of things and availability of things changes, so off the top I'd have to say $500,000 maybe. That's really off the top.
Oh, sure. Would that be all equipment costs, or would that also be facilities?
I don't know where if it's, again, it's where can I find the transformers that I once had?
Yeah,
You know, all that stuff and the wires that's still around. Like, things change, scrapyards come and die, unfortunately. Convoy electrical machinery came and gone. So all that stuff is very scarce. Unless, of course, you buy it new, and that's where the cost would probably come in.
Oh, sure. One of the things you indicated before, though, is if you buy it new, it doesn't always work the same, right? You have to retune everything, probably.
Well, yeah, that's the major thing is the tune-up, about 6 months.
6 months to tune it up. So 6 months and probably $500,000. Still, in terms of a lot of the projects, you know, and they would be guaranteed a result, which they don't see with a lot of the projects they invest in, so that would definitely be helpful. So.
I never guarantee anything.
Yeah.
Oh, no. I say you take your chance, and I've said that to everybody.
Oh, sure, sure.
You know, just because I don't want to overstep my bounds and promise something that I can't really. It's got a lot of ifs, and that's the same with the crystal power cells. I say, well, they're pretty well useless, but if you're interested,
oh, sure, sure,
go for them, which some person already has, because they can be used as basically a detector or a small reference voltage.
Yeah, yeah. Well, and I mean, at least it's good to get a firm dollar value. Yeah. Now, you'd mentioned 20,000 in the past. Is that the kind of the scrap value for a lot of these parts?
Yeah, that's going out and getting it from surplus.
Oh, okay. So a lot of it depends on if it's new or if it's used and where you can find it and what the.
Yeah, because in the old days they would give the stuff away.
Oh, sure, sure.
They just didn't want to deal with it. They said, "Take it. We'll be happy to give it to you."
Yeah,
and I was happy to take it.
Well, electronic breakage is worth a lot of money now by the pound. So it's much tougher to find this kind of stuff.
Well, it's like the big transformers I once had. They were 0 to 200,000 volts DC. Siemens X-ray transformers, and they weighed around 1,500 pounds to 2,000 pounds each. And the scrap guys would get them in, and they didn't really want to bother with all that oil and that, so
yeah,
they've delivered them to me. But prior to that, how I started out was with these unique high-powered neon sign transformers, and a 400,000 volt antique transformer that was, I guess its weight was around pushing close to 1,000 pounds.
Well, as I understand it, the equipment, and again for the classic, I guess, documented Hutchison effect, wasn't the equipment requirement there you using 3 Tesla coils, and then you were using a Graaff Generator?
That's right.
And then RF equipment, right? Now, was
That's RF equipment.
Oh, okay.
Yeah.
Okay. I was just trying to figure out what the setup was there.
It was it's kind of like this in a way, but it was more high voltage looking.
Oh, yeah. A little bit more spacious probably too.
I mean, I would have to work the controls like this while George was standing behind me filming everything. That's kind of funny. Especially with guests, that was really funny.
Now, what did you use for RF radiators? Did you use just regular dish antennas?
For what?
Radiated in the RF like the microwaves and the ELF?
I'll use dish or simply just rubber duckies.
Rubber duckies, like dipoles?
Not dipoles. I'm trying to say like on walkie-talkies they have.
Oh yeah, coil.
Yeah,
coil
coil.
style.
Coil, yeah.
Coil antennas. Okay.
Little
Well, for ELF coils it work fine.
Then I use dummy loads too.
Dummy loads. Okay.
Yeah, to draw some of the energy because I use high wattage sometimes. And
Coils, sometimes parabolas, sometimes dummy loads.
yeah. All depending, because if I use the proper wavelengths on some of these things, then it would radiate all over the place outside and cause havoc.
I wondered, did you ever get any complaints about interference?
Not the only interference complaints. Maybe once, but the only interference seemed to be the gravity effects. That was actually back in Lynn Valley, North Burnaby, and especially here, it's very problematic here. If I try any experiment here, it's like the police come or...
How do they know you're running something?
People start phoning into City Hall. And the mayor was actually here.
What's the complaint?
Concrete's cracking. Oh, yeah, and then the neighbor next to him, Lee Denise, her name is, had some of her ornaments start melting on her.
Ornaments melting. Yeah, that would be considered a side effect.
So, in consideration of this here, I think, well, I don't think...
Yeah. It's not, you don't want to turn it on here because you're living in tight quarters here. So it's better to be away out in a...
Well, it's...
Something that's isolated.
Well, the thing is that there's too many people too close to it.
Yeah. So do you think they're safe, or... I mean, have people ever had ill effects?
No.
Have you ever suffered any ill effects running this stuff, or nothing?
Just radar clicks. George Hathaway's raised 2 healthy children, he said in a video interview, and he's very well healthy because he spent a lot of time with me on these.
Yeah.
The long burns in the 80s.
Still extremely good health for someone his age, just like you are, so yeah.
Oh yeah. We always made sure we were protected too.
Yeah, that makes a difference.
Well, what kind of protection were you guys able to use?
Any kind of shielding.
Shielding.
All types of shielding.
Oh, like Faraday cages and stuff?
Yeah.
But wouldn't those also kind of absorb and negate some of the effects?
Well, we took our risks in those days. I remember it. You know, it's even the colonel and the gang from Los Alamos, they were walking around recording everything, and they had these little round bulbs that would glow up, and they'd test this and test that.
Field strength, yeah.
Yeah, so that was the good old days. We just let her rip, kind of thing, and I'm still that way now.
Ever taken like field strength measurements yourself with any?
Had a full monitoring lab unto itself.
Oh, okay.
And
so
Hathaway.
What kind of field strengths do you remember?
Well, yeah, it's all written down. George Hathaway.
Oh, George has all that. Okay.
And I have it too, actually, in this book.
Yeah, I just interviewed George, and one of the things that surprised me, I don't know, for whatever it's worth, was he said he wasn't sure if it was psychic. He said he honestly didn't know one way or the other. But the only reason he said that, he admitted, was he literally didn't know of anything in electromagnetism that would explain it.
Mm-hmm.
So, but he did mention that he was getting ready to write a biography about his experiences working with you.
Okay, that's probably the book where he's been talking about for the last year and a half.
Yeah, he was literally just thinking about transcribing his thoughts into a biography, which is kind of neat. So,
just got some good mail from George on some of the tests we've done. This is most recent from George in Toronto. Goes into the metal analysis.
Oh, okay.
Cool stuff, Tim.
What are let me see, he's done some...
He's done some XRF, X-ray fluorescence. Let's see, he goes...
Oh, he's done scanning electron microscope work, too.
Yep.
Yeah, that'd be
And gives off some of these. Basically, the like the Hutchison aluminium sample virgin materials, seems that these reports here that are most recent are very similar to the reports back in the samples he did in the 1980s.
Do you think I could photograph the SEM results? Or like maybe, well, probably in a few minutes when we have a little bit more light. But
yeah, so the relative abundance of the alloying and trace elements are still a mystery, according to George. And he goes into details in all the different experiments he did on this and why some of the stuff happens like that.
I wondered if this might not be an electron orbital process. You know, by shifting the valence electrons around, maybe it could create some of the chemical recombinations.
Well, it seems that all the impurities congeal.
Congeal.
Yeah, it seems that the other person that's able to do this too, I believe, is Ken Shoulders in his charged cluster technology.
I've heard that.
Ken's been here many times, and I've been at his home down in Bodiga. Now he's moved to Eureka.
Huh.
And actually, he's meeting with a friend of mine from Switzerland, I think on the 10th of October, with Henry Dakin for some reason. So I don't know what that's all about. He's just somebody who appeared from nowhere from Switzerland.
Yeah.
He represents the Bollard group, I believe it's called.
Oh, okay. Now they're interested in possibly investing, do you think?
Could be. It could be. I don't know. This gentleman came out here just to see me. Flew out and went back to Switzerland, took a few metal samples, and made contact again that he wants to test some of my little power cells.
Oh, okay.
So he sent out $500, which helped. And he'll send me the other $500 when I deliver the 10 little cells.
Oh, awesome. Awesome.
So that will help out a bit. And then he wants to see if it's possible or what he can find out about the Hutchison effect through Ken Shoulders and Henry Dakin.
Oh, sure, sure.
I think Ken Shoulders and Dr. Rauscher would be probably better suited than Henry. Henry's more of just, he likes to just tag along and see what's going on.
Yeah, yeah.
He's an interesting character, Henry is. His parents are known for the famous Dakin teddy bears and toys and stuff like that.
Oh, okay.
Yeah.
Okay.
He's kind of known as the second mayor of San Francisco. He talked to me for 14 hours once on the telephone, couldn't believe it.
Oh my gosh.
This is your home-built Tesla coil. Yeah, and I love the lacquer on this. The lacquer job is just gorgeous.
50 coats.
50 coats of lacquer.
Oh, I believe in military ruggedness.
Yeah, absolutely.
Must have been a designer of something. Maybe battleships or something, I don't know.
Yeah. Yeah, I've heard the name Roland Brito in the past.
Yeah, he's was my sponsor for Germany, for going into Germany, and then he brought in a team of scientists. Like, some of the names I remember is Dr. Amann, Berlin University, and the Bundesrepublik Approving Materials, Dr. Bachmann, that's his name. Bruno Bachmann. And then there was a whole group in Stuttgart.
Oh, okay.
That we had a major meeting in there that day, I remember. I got some of the text and stuff from that. So there was a lot of research. I was invited actually to work and live in Germany.
Really?
Yeah.
That was nice of them.
And they paid to have the entire 22 tons shipped over there, but it never made it.
It never made it?
No, the Canadian government stepped in and trashed the lab and got rid of it.
So that's why it's been so difficult to recover in terms of equipment.
Yeah, because they tried to keep it secret too, but it made the front page of the Vancouver newspapers.
Yeah.
Well, why would they do that if it was going to Germany?
Well, there was a lady that documented the entire event. Her name is Electra Briggs. She would talk to these people. There was lawyers involved. There was a standing court order from the BC Supreme Court where the lab was not to be touched until it was resolved what was going on with it. Otherwise, the lawyers say, Kowalski and Company said, don't worry about anything. You folks go to Japan or to Germany. And that was Ian Gazda and myself. Enjoy it. We'll take care of everything here. And we'll send the lab over through All Cargo Express.
Okay.
Rolf Kipperling. So that never transpired. There was a lot of interference, and the lab was finally seized and taken away.
Yeah, yeah.
Which is kind of on, you can see some of the documentation on Spaces, MSN Spaces. So the Canadians got involved because of previous letter I got from Chuck Cook that says this is a matter of national security about my work with the Canadian government, and that they wanted him to limit his involvement in trying to find the files, the videos taken in 1986.
Oh, sure.
So I have that actual letter and all those documents stating that. So it's kind of intriguing stuff, X-File-ish kind of stuff going on. So when I returned, I met with Richard Glue of Environment Protection Agency, and he handed me documentation and papers, which then I went over and got my firearms collection out of storage and some electronic stuff, and then basically I got so fed up I just sold everything.
Yeah.
I decided to go back to Europe. But then things changed, and as they do in life, and
Ended up back here.
ended up back here, not immigrate. I was actually going to immigrate over to Germany and live in a village called Belzig by invitation. Excuse me. So other things kind of intervened. It was my Japanese friends that intervened, and Yin changing her mind, and we got back together again, and we started traveling through the United States, and I gave lectures down in Denver, Colorado, and things started just rolling along and rolling along.
Oh, yeah.
I thought, well, I was collecting stuff again. I got re-sparked to be enthusiastic, but I was collecting more for the interest of the machines. Then it was around 1999 that I thought, can I really do it again? The levitation work, and I did it for Fox TV.
Oh, okay.
It was Ghost Best Evidence Caught on Tape, where they filmed here. I had a toy plastic UFO flying up in the air. And that aired April 29th, I believe, because the New West Police were, after that film there, they got kind of involved in everything too.
Oh, was this the one where the TV flew off the shelf of the neighbor's house?
No, one of those stories.
It's hard to tell.
Yeah. So anyhow, that... Oh, somebody dropped their watch.
You okay back there, Harold?
Oh, yeah.
Oh, just want to make sure.
Yeah, all right.
When you did earlier experiments on this stuff, John, did you ever run a spectrum analyzer in the background to look at what kind of emissions you're doing, or
Well,
is there ever any recording in terms of spectrum analyzer measurements?
Yes, actually later on, when I could get the equipment, which I had, I was doing that. And then George Hathaway had his equipment, which he then measured all the different frequencies.
So George has some spectrum analyzer data on that.
Yeah, and actually I got a copy of that right here, actually, some of this material.
Oh yeah, I'd like to see that sometime.
On the big lab. It's just around the corner. Pace puts out a little book called The Hutchison Effect. So they give some of the diagrams of the big lab.
Oh, that's Andrew McCroskey.
I would like to see that. I had no idea that was...
Yeah, Andrew McCroskey. Dr. Andrew McCroskey.
I didn't realize that had been published.
Yeah, that was published some time ago. There's a lot of stuff published. It's just a matter of where it goes.
Yeah.
Yeah, it's not organized. It's not cohesive, and so people see a little bit here or there. They see little bits and pieces, and they're not sure what it means. But
it's kind of like me when I was in Austria. I was finding bits and pieces in German publications, and I would go down get it photocopied, slowly put together bits and pieces on it.
yeah.
I'm still finding out stuff to this day. Especially after meeting Nick Cook, I found out all kinds of stuff that I didn't know about. But
yeah, Nick is an interesting fellow.
He was here, and that's quite a while ago now. And then he went off to do that special TLC show. Then up came Boyd Bushman.
I didn't realize Boyd came up to visit.
No. I'm just
Oh,
saying.
I'm sorry. Oh, you mean just in terms of his topics?
So you do have an older spectrum analyzer.
And then
So what kinds of stuff are you finding here, Gary? What are you taking notes on?
My real interest has been with the transmitters, because you've got quite a collection of transmitters. And of course, for the material effects, it would be very interesting to know what the frequencies are. So I'm trying to get a feel for what kind of transmitters you have and what frequencies you're capable of, you know, to try to get a feel for, well, there may be resonances within the materials that you might be hitting. And I was interested by your comment on the frequency shifting. Perhaps the frequency needs to shift a little bit in order to find these notches, these absorption bands in the material. If you're not shifting the frequency, you might never hit these notches. So the fact you're shifting the frequencies, you know, that was an interesting detail to me.
Well,
yeah, I had to lock them up, keep locking them up, because heat, humidity, and that would cause things to shift, and always adjusting them. There's one of the RF operators, I think, is just above your head over there.
Oh, these control panels?
No, just this great big gigantic space gun thing. You should observe that. It's kind of intriguing. Falls into your area a little bit there, just above your head now.
Oh, you mean the megawatt laser?
Yeah. This thing.
Well, Gary, could you elaborate on that a little bit? The charge carriers and the...
Yeah, he's using a nuclear unit, a nuclear emission unit here, and that's one of the things he's using as an ion source for charge carriers for electrostatic field. So instead of electrostatic field normally is just simply displaced charges, here he's creating a space charge with electrons and with alpha particles, which are helium nuclei. And so I'm curious to see what's forming the plasma here. It looks like it's not just a displaced charge effect, but also a plasma effect.
Now, is that the Hutchison effect in general?
Yeah.
Or?
Yeah.
Oh, I'm sorry.
They're not reading your warning signs.
I guess not, no. Good grief.
Okay, this
That's because all the guns are pointing the other way in there, right? They're all...
Okay, I'd like to write down this ISBN on this reference number. If it has an ISBN, I can usually get it.
You want to read it off, Gary?
ISBN is 0-919969-34-8, 1996.
Okay, and I'll...
That long ago now. Oh.
Yeah, time flies. Almost 9 years old. It is 9 years old.
Yeah.
That's the ISBN number.
Unbelievable.
And that is Planetary Association for Clean Energy, the Hutchison file. And then there's your ISBN.
Andrew doesn't seem to make his pace that known out there. He's even finding his website's very hard to try and find that.
Yeah, it has been kind of difficult to learn a little bit more about it. Well, what do you think, Gary? Having seen the lab, what are some of your thoughts from a scientist's perspective?
It's tough to collect all my thoughts right now because there's such a huge array of different transmitters and mixers and antenna controllers that I need to process it a lot more before I can ask any more intelligent questions about everything you've got going here. But it was an absolutely fascinating visit from my point of view.
Okay.
Really neat setup, and I really enjoyed also hearing about your Tesla coils and your electrostatic sources, your Van de Graaff, and how you're using those together. To me, was interesting. It sounds like you might be manipulating plasma a little bit, which plasma physics is, a growing area that's very interesting from the point of view of what kind of effects it can create. So it was neat to hear the tie-in with the charge sources and your ion sources here as well.
Okay. Some of the older info in there would really be interesting to you too, because it uses actual low inductance type capacitors, which were used in plasma experiments.
Oh, really? So that's where you got them? Okay.
From University of British Columbia, surplus.
Oh, thank
and
you.
Those things actually were like, I'd have to say each one of those capacitors is roughly over 100 pounds each.
Pretty large. Are those air caps? Oil caps?
No, they're these guys here. They're I had them arranged in a way that I guess like that. There's a diagram. These are the big caps, and then it explode here through a huge, gigantic gap. Like a big explosion. Then, through that explosion here, I'd sometimes get fireballs, which I'd guide down this tube.
Oh, I see.
So this was charged electrostatically. This is another experiment. These were small corona rings on plastic pipe, suspended. And when this discharged, I might like put a piece of metal bolted on there, let's say. It vaporizes, turns into a little bright fireball, and I'll shoot it off like through that system there.
So it's almost a gun of sorts.
Yeah.
For fireballs.
This total weight of this whole unit would have been maybe 3 tons.
How long do you think it would take for a charge-discharge cycle on this?
60 seconds.
60 seconds?
Going full bore, yeah.
So how far would this fireball shoot, though? This is a plasma ball, right?
Yeah, a little ball like that. It'd go maybe up to 12 feet.
12 feet? It's not too bad.
Until it just disappeared.
Oh, I see.
I think it just ran out of fuel or just disappeared.
Just ran out of juice, probably, yeah.
Sometimes you get the bigger ones, which were sort of semi-transparent, and then they just hit something and go in a different strange directions. But it's getting into like some of the transformer sizes, like this one here. I'd charge up for an experiment. This would be almost 2,000 pound transformers at anywhere from 200,000 to 400,000 volts. And I'd be running a single lead up to this huge gigantic donut, which would charge up on DC, just to try an experiment and see what would happen.
Okay.
And then down here I'd have it with an interferometer. I'd use like rare gases in there, noble gases. This thing would start to oscillate and trigger a whole battery of other equipment in a way that effect would happen. This is in the late 80s, where things were getting more advanced and I was understanding a lot more. And getting into like metal shapes for reflection of statics, RF and that, I'd make these kind of tunable and have pulsating magnetics, variation electrostatics. On this system here, it's known as a spiral spark gap. The spark starts here and it goes right up to here and starts over again.
Oh, okay. Okay.
This is the alpha beta flux in here, 200 millicuries. And this had a shaved down area, milled down area where it's very thin, so that this could be rotated, so the alpha beta flux could be moved around in any direction, at least this way, like traverse. And this is under high tension load, this whole system of tubes and that. So, and this here, of course, is the famous pulsed magnetron, which was pulsed through the proper transformers, but also as a rotary gap run by a motor.
Oh, okay.
So I could adjust the speed or slow it down.
So that created a pulse field.
Yeah. Then I got into getting more exotic here with these huge, gigantic double loop antennas, where I have wires running through here, but under load.
Oh, sure, sure.
To set up a very weak magnetic field to steer and move the electrostatics around. I think we're getting into Europe here. Oh, here we go. Here's the static generators. This is half a mil volts Graaff Generator, and this is one of the ones I built myself. It was like several million volts. That was quite a fun thing. It was on casters, as you can see. And during the summer when it was hot, Tim, we turned this thing on to cool ourselves off through the ionic wind.
Oh, I see, because it produced so much wind it would, yeah, get rid of the boundary layer. Okay.
It just totally, even our lighter wouldn't work in this thing. And we use this one to even guide the stream towards us.
I wouldn't want to be in the neighborhood when you're running that thing.